This is 32nd question we're going to solve of limit chapter, and I think this is one of the easy question, if you have learned the previous videos. Well, let me read this. If f of x equals to blah blah blah, whatever it is, the conditions are here. For what integers of m and n does the limit x tends to 0 f of x and limit x tends to 1 f of x exist? To exist any limit, as I told you, we must get left hand limit equals to right hand limit. So any time if we are getting the satisfaction of this condition, then that time limit will exist, otherwise not. So let's solve the first part. Limit x tends to 0 f of x. Alright, whether it is going to exist or not, we're going to check. Alright, for that let's find out left hand limit. Left hand limit will be limit x tends to 0 minus, in the graph, if you see, if here x equals to 0, this is the line x equals to 0, then we are going to approach from the left hand side. It means it is slightly less than 0. Alright, keep that in mind. F of x and limit x tends to 0. Now you tell me, my dear friend, what will be the most appropriate function among these all for x less than 0? Alright, see here x is greater than 1. It's not gonna possible. It's not possible. Here x is between 0 to 1. It is equals to 0 and greater than 0, equals to 1 and less than 1. So this is also not suitable. Here x is less than 0. So it means this is our most suitable form. So it's mx square plus n. Alright, and let's plug the value. Then it will be m times 0 square plus n. So it's n. Now let's find out the right hand limit. Right hand limit means we are going to approach from the right hand side. Alright, that time x would be slightly greater than 0. Alright, so it will be limit x tends to 0 plus f of x. And now, my dear friend, again your chance. Tell me what is the most appropriate function among all for this condition when x is slightly greater than 0. X is greater than 1, not possible. X is less than 0, not possible. So here x is between 0 to 1. Alright, including 0 and including 1. So definitely this is our choice. That is nx plus m, and that is going to be n times 0 plus m, that is m. And the question is saying, for what integers of m and n does this exist, this limit exist? So for the existence of this limit, as I told you, left hand limit and right hand limit must be equal. So left hand limit and right hand limit must be equal. It means n should be equals to m. So what I can say, if m equals to n, then limit x tends to 0 f of x exist. Alright, so the integer, m should be always equals to n. Alright, then only this limit will exist. Now let's go for the second question, which is limit, let me write first the question itself. Limit when x tends to 1 f of x. So whether it is going to exist or not, what will be the condition for m and n to exist this function, to exist this limit? Let's check it up. Alright, first we need to find out left hand limit, and left hand limit will be limit x tends to 1 minus f of x. So here x is slightly, very small, a little smaller than 1. So when it is little smaller than 1, then you tell me, my friend, what will be the most appropriate function? Little smaller than 1. It is less than 0, it is greater than 1. So this will be our choice, nx plus m. Alright, so limit x tends to 1 minus nx plus m. Let's insert the value. So it will be n times 1. Alright, and then plus m. So it will be n plus m. Now let's find out the right hand limit. And the right hand limit will be limit x tends to 1 plus f of x. Again, limit x tends to 1 plus. Now here x is slightly bigger than 1. It's greater than 1, a little greater than 1. So what will be the choice? This is definitely less than 0. This is between 0 and 1, including 1, and this is definitely a little, or maybe very bigger than 1. Alright, so this function is going to apply for all those which is greater than 1. Alright, not including 1, greater than 1, and this time this will be our choice. That is nx cube plus m. Alright, that is nx cube plus m. And let's insert the value. N times x is here 1, so 1 cube plus m, that is n plus m. What a beautiful news! Again we got n plus m and n plus m. It means our left hand limit and right hand limit is equal. It means yes, the limit exists. So for all values of n and m, limit x tends to 1 f of x exist. All right, and by the end of this question I'm going to end the limit chapter, and I believe you got a very wonderful concept from this chapter limit. If there is any more confusion, any doubt, any suggestion you need to give me, then please feel free to comment below this video, or you can give me the feedbacks on in my channel or in my website, anywhere, right? I'll be really happy to hear something from you. And now we're going to solve the questions from a derivative. All right, and the 33rd question will be the first question from the derivative chapter.